Revelator John.
Hello Revelators, welcome to Revelator John on another video on weather theory. So today I'm going to be talking about the difference in weather between the equator and that of the poles. So here I have a very basic ball which is the Earth. So here is the equator and here are, well, let's say here is the equator and here are the poles, north and south. The light source, the heat source is the sun. Okay, so pretty much the equator receives most of the sun. Okay, so the sun is its greatest intensity at the equator. As depending throughout the year, the North Pole or the South Pole is tilted towards the sun more. Okay, so but in essence the equator always gets more sun. The sun rays hit the Earth, the equator, closer to 90 degrees, whereas at the poles a lot less, as you can imagine. So the sun is greater, the effect of the sun is greater at the equator than at the poles. Therefore, there's more heating here at the equator, less heating here at the poles. Therefore, you have greater expansion of the air, the atmosphere here at the equator. So you get a much more vertically developed atmosphere at the equator, somewhere in the region, let's say 60,000 feet plus, let's say, of the atmosphere here. Of the tropopause right here, the first layer of the atmosphere. At the poles, it can be anywhere from 20 to 30,000 feet because it gets a lot less sun energy, therefore it's a lot colder, a lot less energy within the air molecules, so they're not as vertically developed. The atmosphere isn't vertically developed. So the air around the equator, a lot more vertically developed. Usually a higher pressure system because it's beating down on the surface as well, but also you will have, because it's warm air, it will be able to retain more moisture. The colder air at the pole will retain less moisture because it's cold, but also because it's really cold, more dense, there'll be still quite a lot of pressure building down, although the atmosphere isn't as high. So we could also say that is a higher pressure, and at the equator is a higher pressure. In between the equator and the poles, you could argue that there are lower pressures. So what happens is that the higher pressure from the equator moves towards the center. The higher pressures from the poles move down, and so then you get this kind of high-low pressure mixing at the middle latitudes. Okay, so that is when the axis of the Earth is tilted towards the sun, so you get northern hemisphere. The southern hemisphere, the South Pole, okay, is tilted away from the sun. It's hardly getting any sun at all. You know, in the longest days, no sun at all. You might get 1 or 2 hours of sun. The opposite is true when the southern hemisphere, the South Pole is tilted towards the sun. The northern pole doesn't get any sun either. So South Pole doesn't get any sun. Therefore, it's very, very cold. Very, very cold. Virtually a very low vertically developed atmosphere, 15-20,000 feet, for example. Very cold, but there's still higher pressure there, so it is still moving down towards the poles. From the equator, it's again moving, a higher pressure moving down. So in the northern hemisphere, when the Earth is tilted towards the sun, you'll get more of a dynamic effect of the pressure systems interacting with each other. In the southern hemisphere, there'll be less of a dynamic effect. but overall it will be a lot colder, and you still can get severe weather during that period. In the northern hemisphere, it will be a lot more dynamic, a lot more differences, but there'll be essentially better weather in that process. Around the equator, a lot warmer, and the poles a lot colder. Around the equator, a much more vertically developed atmosphere and ability to hold a lot more moisture. At the poles, a lot less vertically developed atmosphere and a lot less ability to maintain water. So we're going to have moist air, warm air here, so at the equator. So depending on the time of year, you might have tropical storms, lots of daily thunderstorms, that kind of thing. Lots of high temperatures, high humidity, that kind of thing, depending on the point of the earth and what the geography is, whether it's oceanic, whether it's land mass, so on and so forth. At the pole, it'd be a lot colder, so more stable. However, because of the geography over a water mass, ocean mass, maybe liquefied or maybe frozen, that will determine largely what kind of weather you'll be getting at the poles. Okay. Well, I hope that explains the difference between the weather at the equator and at the poles, albeit in a very simplified way. Thank you.